friends, and welcome to a new video. In this video we are going to solve the exercise that related to lesson 1, electric charges and electric forces. Recall that the electrostatic force can be calculated using this formula: F is equal K Q1 times Q2 over R squared. One more time, F is equal K Q1 times Q2 over R squared, where F is the electrostatic force and it should be in Newton. This is the SI unit of the force. K is the electrostatic constant or Coulomb's constant, which is equal to 8.99 times 10 to the power 4. Q1 and Q2, both of them are the quantity of charge, or basically the electric charge, and the unit of the electric charge, since it's a physical quantity, it should be in coulombs. Finally, we have the separation between the two charges, and the symbol of this separation of this distance is R. SI unit of this quantity is in meter. Notice that on the left hand side we have SI unit, so we should make sure that on the right hand side the units are in SI unit. All the units on the right hand side, this is the left hand side, this is the right hand side, should be equal. In other words, if on the right hand side some of the units are not in SI units, we need to do the converting. So we need to convert the non-SI units into an SI unit in order to get SI units on the left hand side. Moreover, we know that this relation gives us the links between Q1, Q2, R and F. So we can from the relation say that R and F are inversely proportional. What do we mean by inversely proportional? It means that as R increases, what happened to the force? Inversely proportional, which means it will be decreased. Also, we have Q1, Q2 and F. The relation between them is direct proportionality. What does it mean? It means if one of the charges or both of them increases, what happened to the force also will increase. So increase, decrease, increase, increase. Now let's try to solve this question. Write true if the statement is true and false, or F if the statement is false. If the statement is false, correct it. So we need to correct the statements. If it's false statement, two pointed charges Q1 and Q2 are separated by distance R. So in the first case 1, we have the following information about our system. Q1 is the charge of the first object. Q2 is the charge of the second object, and the separation between them is R, and we know that K is constant, so it's basically we should substitute it as every time as 8.99 times 10 to the power 9. This is first case. Later, if the magnitude of both the charges are doubled and their separation is also doubled, so case 2, we have doubled the charge as well as the distance between them. So the new charge, you can denote it whatever you want. I will denote it as Q prime 1, this is the new charge, or the charge after we have doubled it, and Q prime 2, this is the new charge, and the distance or the separation between the two charges also is doubled, so I'm gonna call it as R prime. So this is the first case. This is the second case after we have doubled the charges and the distance. Then the electrical force that each charge exerts on the other one remains the same. Okay, now we need to prove or to check out if the statement is true or not. We need to use the formula in order to get the answer. How can we figure out, how can we use this formula? So notice that in the question we have a relationship, or there is a relationship between Q1 and Q prime 1, Q2 and Q prime 2, R and R prime. Therefore, we will try to find the relationship between the old force due to this information and the new force due to this information, knowing that the old force is given by K, Q1, sorry, we will use capital letter according to the question, Q1, Q2 over R squared. You can use the absolute value here also. Doesn't matter, because we are trying to figure out or check the statement without doing any numerical calculation. And the new F prime is equal K Q prime 1 absolute value, Q prime 2 absolute value over R prime squared. What does a prime means? Is the new charges and separation. So now, since we are looking for the relationship between F and F prime, what will happen to the force if we compare them together? Let's write here the relationship between the quantities on the first case with the quantities on the second case. Knowing that Q prime 1, according to the question, is equal to 2 from Q1. Since we have doubled the charge, doubled means twice the value. So the new value, Q prime 1, is equal to twice the old value. Also, we have the new value from Q2 of Q2, Q prime 2 is equal double the old value. And the new separation is equal double the old separation. Now, in order to find the relationship between the first force and the second force, what we will gonna do now is we will replace Q prime 1, Q prime 2, R prime with what? With these old values. Since they are equal, we can make the substitution. So, therefore, F prime is equal K. So, we will replace Q prime 1, Q prime 2, R prime with the values that we have concluded from the question. So, Q prime 1 is equal to Q1. We can remove the absolute value because we will not gonna substitute any numerical value here. Time is 2 Q2 over R squared. So over 2R prime squared. One more time. What did we do here is we have replaced Q prime 1 by 2Q1, since Q prime 1 is equal to Q1, Q prime 2 with 2Q2, and R prime with 2R prime. Sorry, 2R. Because the old distance is R, not R prime. Anyway, now, remember that the operation between 2 and Q1, Q2 and Q2 is multiplication. So we should multiply 2 times 2. Therefore, we will get that the new force is equal K 4Q1 times Q2 over, here the square is 4R and 2, so let's square 2. 2 times 2 is equal 4, or what is the square of 2 is 4. What is the square of R is R squared. Now, we have 4 over 4 can be cancelled out because it's equal to 1. And therefore, F prime is equal K Q1 Q2 over R squared. So, we will figure out that the new force, if you want to find a new force, you can also calculate it by using this formula, K Q1 Q2 over R squared. If we go back to the first case, we knew that F is equal K Q1 Q2 over R squared. K Q1 Q2 over R squared should be equal to F. And here we have K Q1 Q2 over R squared equal what? Equal F. So we can replace K Q1 Q2 over R squared by F, and finally we will get F prime is equal, let's do the replacement or the substitution, equal F. What does it mean? It means that the new force equal to the old force. So we can conclude that from this relation that the electrical force that each charge exerts on the other one remains the same. In summary, what we did here is we have found a relationship between the quantities Q1 and Q2, R and R, and which we have tried to looking for at a relationship between the forces. Since we have a relationship between the quantities, electric charges and separation, we try to looking at a relationship between the forces. Therefore, in order to find a relationship with the forces, we need to make the substitution in order to make the link. And this is what we did. After we have found a relationship between the quantities, we have substitute these quantities in one of the relationship, and finally we will get a relationship between the forces. After that, we have concluded that the new force will be equal to the old force. Thank you so much. See you in a new video soon. Hope this video was helpful for you.